Good afternoon, and thanks for joining us for the 16th webinar in the Offshore Wind series, Learning from the Experts. I'm Peter Lyon, Senior Advisor with NYSERDA's Offshore Wind team, and it's my pleasure to be joined today by today's expert, Brent Cooper from COWI, who will be giving a presentation on port development considerations for offshore wind. Before I introduce our speaker, a few reminders for our participants and some background on this webinar series. Next slide, please. Firstly, if you're experiencing any technical issues, please contact John Necrato at the email address on the bottom of this slide. This webinar is being recorded, and the recordings and presentation slides for all webinars in the Learning from the Expert series will be available on NYSERDA's website at the address on this slide as well. All participants have been muted. We'll have a time for Q&A following the presentation, so please use the Q&A function to submit your questions for the speakers. Next slide. So New York State is working to advance the responsible and cost-effective development of at least 9,000 megawatts of offshore wind by 2035. Offshore wind is a critical component in achieving the state's goal of 70% renewable sources of electricity by 2030 and 100% zero emissions electricity by 2040. While offshore wind has been providing clean energy to other parts of the world for several decades, this industry is brand new to New Yorkers. To provide interested stakeholders and members of the public with accessible, impartial information and opportunities for engagement on specific topics of interest, NYSERDA is hosting this educational webinar series called Learning from the Experts to connect the public with independent experts in key topic areas in offshore wind. Through this series, we endeavor to select learning from the expert speakers based on their expertise, not necessarily for an alignment of opinions with NYSERDA or the state of New York. If you'd like to suggest a topic or speaker for future webinars, you can email us at offshorewind@nyserda.ny.gov. Please note that the views and opinions expressed in this presentation are those of the presenters. Next slide. It's now my pleasure to introduce you to Brent Cooper. Brent is a project manager with COWI and has over 14 years experience providing engineering solutions to offshore wind and marine terminal infrastructure projects, especially as they relate to the design of wind turbine foundations, substation foundations, and fabrication and staging port facilities. Brent is responsible for business development and project delivery to clients and manages a technical and geographically diverse team of subject matter experts. Brent and his team provide services through the full life cycle of a project, including planning, analysis, engineering, construction, structural condition, monitoring and assessment, rehabilitation, and decommissioning. And with that, I'll pass it over to Brent. And it seems Brent might be having some bandwidth issues, so please stay patient with us as we work to resolve.
Peter, I had lost you for a bit. Are we good?
Yes, we are all set, Brent. We got through your introduction and ready to go for you.
Excellent. Thank you very much. Yeah, yeah, great. Thank you. So here today to talk about port considerations for offshore wind with a little bit of a New York slant. So next slide, please. Today we're going to talk a little bit about introductions, who I am and why I'm here talking to you today. Well, we're going to introduce the role of ports to offshore wind and why they're important. We're going to talk a little bit about typical facility specifications. So what are the roles and what do these ports look like that are actually helping the offshore wind industry? A little bit of background on the activities and support that New York State has provided to these offshore wind ports, and a quick run through of some of the ports that are trying to be active in offshore wind. Then we're going to talk about what some of the other states are doing with respect to offshore wind ports. A brief view of federal incentives and programs to support these ports as they become operational, and then just a couple key conclusions and takeaways. So next slide, please. So I am a project manager with COWI. I have 14 years of experience with coastal, waterfront, and offshore engineering, with a wide range of projects, everything from marine terminals to support container and marine oil terminals to offshore wind terminals, as well as the offshore foundations to support the wind turbines and the offshore substations. Next slide, please. And I work for COWI, which I like to introduce as one of um, the least well-known large companies around, but we are actually about 6,500 to 7,000 employees globally, headquartered in Copenhagen, Denmark. Here in North America, we're about 250 employees over 9 offices, focused in key landmark infrastructure projects, primarily bridge, tunnel, energy, and marine sectors. We do have about 250 engineers also globally specific that work day in and day out in our offshore wind practice, and then another 200 engineers in the marine terminal side. So this is a topic that's very near and dear to my heart and to the company. It's a nice intersection for us. Next slide, please. As far as services and when I'm talking to you, we're active in really the full range of consulting and design of the infrastructure. So everything from the bottom of the turbine flange into the grid. And enough of that. We will get right into the next slide for the meat of our presentation today. So this is the introduction to offshore wind ports. And I'm going to try to flash up a lot of pictures and we'll move relatively quickly. And next slide, please. So why are we talking about ports? We're all here to learn about offshore wind. Why are we interested in ports? Well, when we look at what offshore wind is, the components that it's made up of, and how the offshore wind farms are constructed, all of the components that go into offshore wind are very large. They're very heavy. They can't be transported over the road network or over the rail network. So we're very reliant on ships and barges to transport these components, whether it be from the manufacturing site to the construction and staging locations out to the offshore sites. Everything has to come in and out of a port to be processed and to go offshore. When we look at nearly 30 projects or 30 potential lease areas in the U.S. East Coast alone, considering most of these projects are split up into 6 or 7 major packages, and a package might be a foundation package, a cable package, an offshore substation package. Each of these packages needs their own ports, so we're looking at siting, it could be 180 to 200 different major port activities to support these projects, splitting those over the ports that we have. Next slide, please. So I'd like to show this slide, and the U.S. has a bunch of really great port facilities, marine terminals. But the question is, why can't we just use these for offshore wind right away? Well, we have to look at the role of the more traditional ports versus the needs of the offshore wind ports. And we look at the location of a kind of a traditional port, whether it be to support container traffic, liquid bulk, solid bulk, passenger traffic. The location of a traditional port is generally as far upriver towards a population center as can be. With an offshore wind staging port, we want to be as close to the offshore location as we can be to minimize the transit times back and forth. Water depth generally required deeper for a traditional port. We don't generally tend to need quite as much for offshore wind. But we do need air draft, which is the distance from the bottom of the or the water surface up to the top of whatever vessel is sailing through. Most modern bridges designed for 180 to 215 feet of vertical clearance. Offshore wind really needs unlimited air draft. So you can see through here, and I'm not going to read through the rest of the table, but we start to see a differentiation in the needs and the characteristics of the offshore wind ports versus some of our standard ports. Next slide, please. So for the purpose of today's discussion and the way that that New York has often approached this port question, we've kind of differentiated the three different roles of offshore wind ports into manufacturing and fabrication. So these are where the large components are built, they're constructed. They're then shipped to a second port location, which is called a staging or marshaling port. So this is the location where all of the different components come together to a central location prior to being taken offshore for construction. And then we have a third port, the operations and maintenance port. So this is the port active not just the construction during the construction phase, but also during the full lifespan of the project that's supporting the day-to-day operations. Next slide, please. And so when we talk about the different types of controlling port characteristics, I'd like everyone to kind of keep in mind the different needs that we have of the port. So we have the staging area. This is the physical size of the port. How big is the area near the quayside where the vessels are going to be on and off loaded? And how big are the uplands where components can be stored waiting to go offshore? We look at dedicated wharf or quay frontage. So that's the length of the berth where the vessels can come in and out. We look at live load capacity. What are the weights that these structures can withstand? Offshore wind components, very large, very heavy, much higher demand for the offshore wind ports than a lot of our traditional ports. Navigable depth is the water depth of the vessels coming in and out. Air draft is that vertical clearance for the vessels and their cargo coming in and out. We talked a little bit already about geographic location. Where are these ports located and how important it is to be close to those offshore locations. Also important is the access to and the cost of labor. So everyone working at the port and working on the vessels. And then the connectivity to other modes of transportation. And this could be for the smaller components coming into the manufacturing facilities. It could be connection to helicopter transit for O&M, could be connection to rail, again, for raw materials coming in and out. All of these things very important to the ports. So to understand how these different characteristics change, the needs for them change, depending on the type of components that we're looking at, we're going to take a quick run through some of the different offshore wind components that we're interested in and look at the demands that they start putting on the port facilities. So next slide, please. Starting with the turbines, this is what people like to talk about first. I'd like to show how the demands on the port facilities are changing with the advancement of technology. All three nacelles here, this is the center of the turbine that goes at the top of the tower. The images here are before the blades are attached, but all three of these turbines are GE machines. So the top center turbine is a 1.5 megawatt turbine that's typically used in onshore wind. Top right is a 6 megawatt turbine, like was used in the Block Island wind farm. And the bottom right and the bottom picture is the new GE Haliade X, the 12 megawatt turbine. So as this technology has advanced, we've gone from 90 tons at the top of the tower to 400 tons and now to 600 tons the top of the tower. We can also see how the size has increased. So as these turbines grow larger and larger, they're placing more and more demand on the waterfront infrastructure. Next slide, please. Then we're going to talk a little bit about different types of foundations. So, where are these, what are the different types of foundations being built? Next slide, please. Next, yeah, there we go. Great. So this is an image, a couple different images of monopile manufacturing, some images that I obtained through EEW. This is the top image is their rolling facility in Rostock, Germany. These monopiles that we are building in these port facilities and then shipping out, they can be up to 10 meters or 33, 34 feet in diameter. Recent designs up to 50 meters or almost 500 feet long, with weights exceeding 2,000 tons for a single pipe. So again, very large, very heavy, lots of demand on the quayside. Next slide, please. Looking at both jackets and gravity-based foundations. These also are used to support the wind turbine. So the jackets can also weigh 2,000 up to 3,000 tons in the greater water depths. Steel lattice structures that are welded together, very similar to what we see in the Gulf of Mexico, but again, needing to look at serial and mass production. How can we turn a lot of these things through very quickly? The bottom image is the Thornton Bank foundations, which were installed offshore of Belgium. Gravity-based foundations are large, singular concrete structures. They're fabricated onshore, launched into the water, and brought to the offshore site. They sit on the ocean floor. Demands on the port facility for these GBFs can be 130 to 150 feet in diameter, maybe 5,000 or 6,000 tons each, up to even 10,000 tons each for the largest generation of turbines. So again, very, very heavy, very space intensive onto the port facility. Next slide, please. So after the turbines and the foundations, we talk a little bit about the electrical side of the projects. All of the cables that need to be produced, medium voltage AC cables, connect the turbines within the wind farm to the offshore substation. High voltage AC cables and high voltage DC or direct current cables will then connect the wind from the wind farm to their interconnection point on shore. All of these, again, very heavy. The cables generally try to avoid splices offshore. So the cables are generally manufactured in long lengths. The carousels that the cables are stored in can also weigh thousands of tons. So the manufacturing facility for the cables are often tried to be on the waterfront to allow direct load out to the ships. Next slide, please. And then as far as the remainder of the electrical services, also need to fabricate the offshore substations. This is a rendering or depiction of the potential South Fork substation, which would be on a monopile. But these are the stations where the electrical energy is collected, transformed to a higher voltage, and then sent to shore. So also need dedicated fabrication facilities for these at the water's edge. Next slide, please. Moving to a different role of the port, now looking at construction and staging ports. These different types of components that we've just gone over generally have their own bespoke manufacturing or fabrication facilities. They're then commonly transported from that facility to a staging or installation facility. At this point, the components are all brought together. They're prepared for the offshore transit to the point they can be. They're pre-commissioned. Maybe the smaller transformers in the bottom of each tower are pre-commissioned. Everything's prepared, loaded onto the installation vessel, and then taken offshore. So the images here are actually the Port of Belfast in Northern Ireland. Try to keep most of the pictures in the U.S., but I particularly like this series. This shows 3 different generations of port usage. Beginning at the top on the left, looking at using graving docks or dry docks for staging for the first projects. The second picture is a rendering of a bespoke built facility for construction staging. And then the third picture is a photo of that facility built out, again, similar location, also in the Port of Belfast, now dedicated fully to offshore wind construction. Next slide, please. And then in the final bin of offshore wind ports, looking at operations and maintenance. So key characteristics here being the proximity to the project so the vessels can get in and out quickly, minimizing fatigue on technicians, minimizing loss of time getting out to the site, and then having space to store these vessels, spare parts, and provide for the technicians. 2 different images here. On the left is a smaller crew transfer vessel strategy. This is kind of the 60 to 100 foot boats that go in and out every day. They generally come back to shore each night. And then on the right, kind of the new generation service and operations vessel strategy, relying on 250 to 300 foot vessels that may stay offshore for 10 to 14 days at a time. Okay, next slide, please. So then what does all this mean in terms of quantitative facility specifications? What do these ports need to be upgraded to withstand, or what do they need to have? Next slide, please. So this slide is meant intentionally to be maddeningly confusing because of all of the different types of requirements, all of the different types of roles. Each particular role of the port facility has slightly different facility characteristics, and that may be depending on whatever it may be manufacturing or whatever it may be transshipping. A number of the U.S. states have undertaken different port facility studies, and each has kind of recommended a typical type of specifications. But what's important to know is that finding a perfectly ideal port that meets all of the requirements in an ideal world is really a unicorn. We're not likely to find it. But that said, there's a lot of opportunity to work with the existing ports and get as close as we can to many of these different type of specifications to use these different ports. And we'll go to the next slide, please. So moving on beyond the individual roles of the different port facilities, now taking a little bit of a look at what has New York State done so far, and what are the port facilities in New York that are vying to be part of the industry. Next slide, please. So New York began their work with offshore wind ports in 2017 as part of the support into the Offshore Wind Master Plan. The first year worth of study was really trying to understand what we've talked about already today. What are the roles of the offshore wind ports? What are the needs and demands on these facilities? And what facilities does New York have to potentially meet these demands? So that first 2017 study identified 65 potential industrial facilities on New York's working waterfront that could potentially be used. Looking at then a round 2 of the ports and infrastructure studies that was completed for 2018 was meant to take a deeper dive into 4 of the specific sites, Port of Albany, South Brooklyn Marine Terminal, the Port of Coimans, um, and a facility on the north shore of Staten Island. These facilities were approached as a kind of if you build it, they will come mentality. So not looking at a necessarily specific end use, but what might these different facilities look like if they were improved to allow a multitude of end uses, kind of the Cadillac of port facilities, if you will, fully built out. The intent here was not necessarily to build these 4 facilities into the 4 Cadillacs of the offshore wind world, but it was meant to highlight these facilities' potential, to explain what they could be, as well as to distribute technical information about these sites, such as the bearing capacity, the geotechnical conditions, the land area, potential layouts, to convey all of this information to stakeholders who'd potentially be interested in using facilities. Along with this, there was 2 ancillary reports, one looking at O&M facilities, primarily on Long Island, and also looking at potential for full new build facilities outside of New York Harbor that would have unrestricted air draft. So that was really the 2017 and 2018 studies. Next slide, please. Coming forward from that point, NYSERDA launched Request for Qualifications 4259 for offshore wind port infrastructure. This was beginning of an effort for New York State to look at investing $200 million of state funding to improve offshore wind ports, specifically for this offshore wind industry. There were 11 facilities that provided qualified responses to that RFQL. They're identified here on the map. Interestingly, all 4 facilities, the Port of Albany, Port of Coimans, SBMT, and Port Ivory that were in the 2018 Ports and Infrastructure reports, expressed interest and were moving forward at this point. This request for qualifications was then wrapped into the New York's second solicitation, the OREC RFP 20-1. And so that solicitation, next slide, please. That solicitation required in a base bid the use of one or more of those port facilities in the offshore wind providing power to the state. So looking at trying to use those domestic facilities in New York, how could they be leveraged? So this slide actually shows the ports that were identified by the developers, being Equinor and Ørsted in their projects. Yep, that's what we got there. So now we'll go to the next slide, please, and look at kind of a highlight. Not meant to be a comprehensive dive, but kind of some of the highlight facilities that New York is looking at right now. So the Port of Albany Rensselaer Beacon Island expansion. This is located in the Port of Albany. This is approximately 80 acres located south of the existing developed port. This expansion will be operated under long-term lease by Marmon and Welcon, allied with Smulders, and the intent is to use this facility for manufacturing wind towers, so the turbine tower above the foundation up to the nacelle, as well as the transition piece on monopile foundations. Anticipating construction of 500 linear feet of 6,000 PSF wharf, so high capacity wharf for the load out of these components. Construction is expected to start in 2022 with an investment of about $350 million of public and private money. This particular project was originally anticipated to create approximately 350 direct jobs. However, due to the capability that Marmon and Welcon are anticipating having here, it's been a very sought after manufacturing location. We've seen a huge increase in demand and are already projecting 550 direct jobs. Next slide, please. Just downriver from the Port of Albany is the Port of Coimans in Coimans, New York, owned and operated by Carver Companies. This is a large industrial site of approximately 125 acres on the water side, with an adjacent 275-acre industrial park. This is going to be the location of an $86 million supply contract that will construct and supply foundation components for Ørsted and Eversource's Sunrise Wind project. Next slide, please. So the South Brooklyn Marine Terminal is located in Brook, the east side of New York Harbor. It's owned by New York City EDC. Will be operated under long-term contract by SSBMT, or Sustainable South Brooklyn Marine Terminal, which is a joint venture of Red Hook Container Terminals and Industry City. They will in turn initially lease the facility to Equinor, who is intending to use the facility for a staging base for their projects selling power into New York State. In addition to the construction staging, they are also looking to make this facility the home of their O&M base, also potentially resulting in about 350 direct jobs. Next slide, please. So Port Jefferson, located in East Setauket on the north side of Long Island, will become the home to Ørsted's operations and maintenance base. It is a joint warehouse and office facility, as well as berthing facility for their service and operations vessels. These vessels will service the Sunrise and South Fork wind projects over the lifetime of those projects. This facility will result in about 100 permanent direct jobs. Next slide, please. So the Arthur Kill Terminal is in process of development, located on the southwest side of Staten Island, is being developed by Atlantic Offshore Terminal. The intention of being a bespoke, purpose-built offshore wind staging facility. It will ultimately result in about 32 acres of staging area with 1,350 feet of quayside for dedicated inbound and outbound berths. This facility is currently in process of completing their detailed engineering and obtaining their necessary permitting. Construction is anticipated 2023 and will be operational in 2025. Other interesting thing about this facility is this is potentially the only facility in New York State that has unlimited air draft, allowing kind of traditional European models for offshore construction. So now looking at what New York's done in the past and looking at some of these facilities, where do we go from here? I can't speak too much to this, but very interesting in Governor Hochul's 2022 State of the State address is that New York State will dedicate $500 million to support offshore wind port infrastructure and supply chain and manufacturing investments. So this is anticipated to be a huge benefit for additional facilities coming online and supporting the offshore wind industry. It's also key that the facilities receiving this money will be a key element of the third RFP or the third procurement of offshore wind energy for the state. So that is New York, and we can go to the next slide. And so we'll just take a quick look at what some of the other US states are doing in terms of the facilities they're developing in their studies. Next slide, please. So state of Maine, we're going to go kind of north to south. State of Maine is conducting a feasibility study for using the port of Searsport, potentially to support some of their floating projects. Massachusetts, with their renewable energy goals, has a number of ports that are developed or are looked at being developed, including the New Bedford Marine Commerce Terminal for staging. The Port of Salem, a potential additional staging port being developed by Crowley for use by kind of the Vineyard Wind 2 project. The Brayton Point facility used as an interconnect recently announced that there will be a cable manufacturing facility there. Vineyard Haven, located on Martha's Vineyard for operations and maintenance base, as well as the Borden and Remington facility is the operations and maintenance base for Mayflower. Next slide, please. Rhode Island has used the Port of Davisville and Providence for construction of the Block Island Wind Farm and looking at the continued involvement of those facilities moving forward for their wind projects. Also, the Senesco and Windsurf facility located at the Port of Davisville. Connecticut has two major in process, State Pier for staging, and the Port of Bridgeport also potentially for some construction staging. Next slide. We skip over New York with all of our details and go to New Jersey. New Jersey is looking at constructing the New Jersey Wind Port. That is going to be a combined construction staging facility as well as a nacelle assembly. The Port of Paulsboro is being developed by EEW as a monopile fabrication facility, and Atlantic City will be used for an operations and maintenance base. State of Maryland is looking at developing Tradeport Atlantic, the Sparrows Point Terminal, for fabrication of heavy steel elements, and that could be foundation or superstructure. And Ocean City will also be an operations and maintenance base. Next slide. Porter, Virginia is focusing on the Portsmouth Marine Terminal, which will be used both for construction staging for the Coastal Virginia Offshore Wind Project, Dominion's project, as well as a home to a blade manufacturing facility by Siemens Gamesa Renewable Energy. North Carolina, moving southward, is also looking at jumping into offshore wind, and it's conducted a supply chain study evaluating their state's port facilities. And next slide. and a highlight out to California, which the Redwood Marine Terminal and Port of Humboldt is looking to be developed potentially to support some of the floating offshore wind projects out in the West Coast. Okay, next slide. There are a number of federal programs that are available to support the development of these ports for renewable energy. I'm just going to touch on a couple of them, but again, not a comprehensive dive. Next slide. One of the programs that's commonly being used and investigated by the different port facilities is MARAD's Port Infrastructure Development Program, or PIDP grants. This is a program that grew out of the original Tiger funding. In 2021, there was $230 million allocated to the program. 3 ports, including 2 in New York, received money out of that program. So that Port of Albany, Marmon Welcon offshore wind tower manufacturing project received funding, as well as an expansion or extension of the SBMT staging facility. And then Portsmouth Marine Terminal in Virginia also received funding. This is anticipated to continue to be a large funding mechanism and a big help to many of the offshore wind ports. It's been announced that in fiscal years 2022 to 2026, that program is going to receive additional funding. So it'll be $450 million annually, and looking forward to seeing where that funding goes. Prepared this presentation last week, and already my next note is out of date. But the BOEM lease program, BOEM did publish their final sale notice for New York Bight leases. We're not going to talk too much about that today, but I do note that BOEM lease does provide financial incentives for developers to procure offshore wind components domestically, and note that there is a financial incentive along with those leases for developers improving either ports or the domestic supply chain. I will also note, I didn't make it onto the slide, but the Department of Energy's Loan Programs Office has a funding mechanism available for innovative projects. So port facilities looking to implement new technologies to support offshore wind may also be eligible for funding under that program. Okay, thank you. Next slide. And so with all of this information, what are we supposed to make of it? So just a couple kind of conclusions and key takeaways. On the next slide, please. So first, offshore wind requires purpose-built, high-capacity port facilities. The U.S. has a ton of great port facilities. However, they don't necessarily meet the needs and specifications of the offshore wind industry. So there are a few ports that have been built, more facilities there where construction is underway, and even more facilities that are going to be needed to reach the goals of New York State and the other U.S. East Coast states in terms of development and procurement of offshore wind energy. A number of states, including New York, are beginning to prepare their port facilities with a number of the different initiatives that we've talked about. The offshore wind pipeline on the U.S. East Coast will require a large number of these improved and/or new port facilities. It's the sheer volume of projects and the demands and the size of the components are going to require more facilities than are available, and even more facilities that are envisioned to be being brought online or developed now. So there will be increased need. Next, that the offshore wind projects that can be built first will most likely use the port facilities that are available to them, and that a lot of the local economic development is likely to follow the location of those port facilities. The alternative to this is that the offshore wind projects could be held up or delayed if the port facilities are not available. But it does look like most of that economic development is going to follow a lot of these first mover port facilities. And finally, New York, through their programs, through the ports and infrastructure studies, through the funding mechanisms, and through their leases, has made great strides, continuing to make great strides to facilitate the development of both the offshore wind industry as well as the port industry to support offshore wind, and looking to capture a lot of that local economic development. So with that, we'll go to the final slide. And I want to say thank you, everyone, for all of your time today, and look forward to questions and discussion that anyone in the audience may have.
Thanks so much, Brent. I really appreciate the presentation and insight into port development that's happening here in New York, as well as more broadly along the East Coast, and some exciting opportunity it looks like cropping out on the West Coast as the industry continues to make strides there. Please, attendees, send your questions in. We have Brent here, who is an expert in this area and is ready and willing to answer questions. So feel free to put them into the chat function. One of the first questions we had come in related to just expanding a little bit on the time, schedule, and cost of building these new facilities. It sounds like there's opportunities potentially for retrofits, but also seeing a lot of new kind of greenfield sites being developed into offshore wind. So if you could touch on those two areas and maybe break it down into, you know, O&M or stage marshaling or manufacturing, that'd be great.
Sure. So I'll start with the schedule part first. I think that you know, the engineering and development, while maybe not on exactly the same schedule as the offshore projects, can be significant. So if we look at the port facilities need to go everything through a siting phase, a potential use and feasibility phase, concept development, permitting, which can take some time, detailed engineering, procurement, and construction. So the construction of a facility from start to finish could be anywhere from 2 to 4 years, depending on the challenges and opportunities for that site, how much development is necessary. It could be considerably less for a facility that needs a simple upgrade. But either way, these are potentially long lead times that need to be worked into the development of the overall offshore wind project and making sure the overall total program, scheduled program, works together. And then I think, Peter, the other part of that was a kind of a question on the cost, and that's a little bit of a dangerous question to answer because the scope of the improvements or the new build can vary wildly on the different facilities. But I think, you know, what we're seeing with the investment from New York of you know, $200 million in grants and finance being made available, leveraging over, you know, $400 million worth of total commitments, split between a couple sites. You know, it's not for a bespoke, purpose-built, fully developed, large-scale construction or manufacturing port. You know, I think it wouldn't be unreasonable to expect these facilities could cost a couple $100 million if we're starting from scratch.
Yeah, and it's really those public-private investment opportunities and partnerships, you know, is a hallmark of NYSERDA's programs and New York's programs that have helped develop those initial sites. Staying on the topic of development, can you speak to the sequencing that these port improvement projects typically follow? So, meaning what comes first, the decision to invest in a site or an agreement on a multi-year lease term?
There's a certain individual I like to quote. I won't mention him by name here, who often stands up and raises his hand and says, "Well, if a port costs $200 million in the context of an offshore wind project, why are we even talking about this? Why, you know, why don't we just spend the money?" But we have to realize who is spending the money and where their role in the supply chain. So the offshore wind developers are not looking to own and operate port facilities. They're looking to own and operate the offshore wind projects that generate the electricity. So the port facilities are generally owned, whether it be by a port authority or a private corporation who operates with a very different budget. They need to secure a return on their investment. And so with let's say if we're in the context of a construction and staging port, that might be used for 1.5 to 3 years, depending on the project for a single object, can be very difficult for an owner to justify that kind of investment for a potential 3-year use. So it's a little bit speculative on when that investment can become possible. Alternatively, looking at more of a manufacturing or fabrication type of port, those may be used for 20 to 25 years or more. So the business case is a little bit more straightforward. That said, they're still very capital intensive facilities. So for the vast majority of the operators, they need to put together their business case and understand their revenue stream before they're making the investment before they're making the decision to invest. And for a lot of the budgets that these organizations operate on, like I said, that can be somewhat challenging to move forward with a "if you build it, they will come" type of mentality.
This thanks for that. Is very insightful. Thinking about another potential port, we had a question come in around what are the strategies for selecting optimal fueling locations for supply and maintenance vessels during a project here in New York, for instance.
Sure. So looking at the kind of geographic preferences for an operations and maintenance port, these are the vessels that are going back and forth between the O&M port and the offshore wind generating facility. So they're making numerous trips. There's a large desire for those port facilities to be very close. In the context of kind of a CTV, 2 hours is commonly thought of as kind of a maximum sailing distance for a technician to get a usable day. And the SOVs, they can travel somewhat further with the larger vessels, but still the developers are not really interested in losing the money associated with sailing extended distances. So many of these O&M facilities are desired to be as close to the offshore wind projects as possible. There are different strategies for fueling the vessels. As of now, the industry has typically relied on traditional fuels for these vessels, although like much of the maritime industry, there's a lot of interest in green fuels, in hybrid power systems, all of the same type of propulsion discussions that are being had throughout the rest of the maritime industry. But there are different strategies. Most of the smaller facilities will try to have fueling stations on site. That can change for some of the larger vessels, but it all depends on the characteristics of the facility and what can be made available to the vessels on a cost-effective basis.
Yeah, no, on that refueling aspect, I know NYSERDA is always thinking about ways to decarbonize, renewable industries as we're moving forward, and it's definitely one of those questions that is top of mind from our perspective. We had a question come in about how ports are going to future-proof against a constantly developing and growing design of technology, so larger foundations, larger wind turbine generators. And even getting into opportunities associated with floating as we get into deeper water. Can you speak to that future proofing aspect and what any port developer should be thinking about?
Yep, absolutely. That's always a very interesting discussion, trying to peer into the magic 8 ball to tell what the future holds. But I did show a slide about how rapidly the weights of the wind turbine generators are increasing. And so it's a great question. Right now, the port facilities, the specifications for the live load capacity and the material handling is really based on the equipment that can be used to move those different components. So in the case of a self-propelled modular transporter or these multi-wheel transporters that are often hooked up in series to transport the heavy components, um, that type of equipment can generate certain live loading or certain pressure into the ground. And it's limited by that equipment. And you add more of that equipment um, to carry heavier weights, and then that load is spread over a larger area. So right now, the thought is to rely on the latest generation of equipment that's handling the weight and provide for that. But that said, at some point that will reach a limit too. So kind of state of the art is looking around, kind of 3,000 PSF in to support multi-wheeled the SPMT movements and higher loads depending on the cranes.
Thanks, Brent. When we start to think about port design and investments, how can we take into account and incorporate environmental justice concerns of surrounding communities? Are there any best practices there that you can speak to?
That's a great question, Peter, but I'm going to push back a little bit, and that's pretty far outside of my role. I'm kind of the nuts and bolts steel and concrete guy. The only part that I can add to this is that a lot of the ports do come along. There is a need for skilled labor within the port facilities, no matter what their use, and they do come often with a number of good-paying jobs. But I really, beyond that, I'm not the qualified one to speak to social and environmental justice.
Well, I think we've got a future session in mind then as we think to another Learning from the Expert webinar series. Another question that came in relates to specifically Long Island. I'm trying to find it again. So regarding Port Jefferson O&M facility for Sunrise Wind, what characteristics could incentivize development there compared to further east on Long Island? What are the unique needs of O&M? So kind of a two-part question.
Sure, and I don't want to speak for Ørsted because I'm certainly not part of their decision-making process. But just generally looking at the needs for an O&M facility, when you're looking at trying to use an SOV or a service and operations vessel, these are the larger vessels that are 250 to 300 feet long, stay offshore for generally 2 weeks at a time. You need to find a harbor that is large enough and deep enough to accept those vessels, and also to provide safe berthing in terms of severe weather events. So up until a very large storm, these vessels will come into port. They need to be able to take shelter. So just looking at the size of the port facilities, the size of the particular marine terminals that might be available, and balancing that with the proximity to the project.
Right, and generally these O&M ports are supporting one project, numerous projects.
Yep. Also a good question. There is that's a little bit in flux, and it depends on the facility and the project. There are certainly examples in the offshore wind industry of purpose-built O&M facilities that support one project. There's also examples where there are O&M hubs that can support multiple projects. And it could be multiple smaller vessels, multiple CTVs sailing out of there, could be multiple SOVs sailing out of one location. And there's even precedent in the market for O&M hubs that are operated concurrently by multiple developers to serve multiple projects. So it's that the answer to that really depends on what that particular facility is able to support and how many offshore wind projects can be reached within a reasonable sailing time.
And is one of those primary determinations acreage? So for a single port, what would be the average acreage? And for more of a O&M hub, what would be an average acre? acreage people should think about?
The acreage depends. The short answer, yes. Each operator or each vessel does have a certain requirement for a certain amount of land area. And that O&M base could have a number of different activities going on there. Everything from office space, if the wind farm is being operated from that location, or if it's being operated from somewhere else. There's a certain amount of warehousing as well as open laydown area that's required for parts and equipment, spare materials that need to be transported back and forth to the wind farms. Depending on the location, there may need to also be dormitory facilities for technicians if there's not housing readily available. So the needs and demands on the O&M facilities can change quite a bit. Again, that land area changes pretty widely depending on the particular strategy.
Great, thanks. I think we'll get to two more questions before we close out. And there's one that I thought was good. Does the pace of port development along the eastern seaboard appear to be on track to support the pace of the proposed build-outs of both onshore and offshore wind construction requirements? If not, how could the gap be addressed?
Great question. There's a number of people trying to answer this, and different models that different agencies and organizations are putting together, looking at the different proposed port developments. When will they be coming online? Will they be online in time to support the various offshore developments? And then what happens to them? Depending on which model you look at, you can answer that question differently. Some show that there could be enough facilities brought online. Other models say that additional development is necessary. So it kind of depends on which model you'd like to follow. But that said, there's going to be a huge number of facilities that are required if the states are going to try to procure all of their energy in accordance with their schedules. So there's still a huge opportunity space, I think, there for additional ports to become involved.
Right, and one that I saw that came in at the beginning, as we think about the trajectory of the industry and potential even other uses of ports associated with maritime commerce. What are other functions these offshore wind ports could serve? But this, as it relates to like heavy infrastructure projects or other types of commerce.
Sure. So the investment that's required for an offshore wind port, as we talked about, can be quite significant. And the facility requirements in terms of live load capacity, laydown area, exceed what's often needed for other industries. That said, there are some construction projects that could leverage these facilities. If there were an availability, taking a look at kind of any other major infrastructure projects could potentially also benefit from the ports. So whether it be a large bridge construction, large tunnel construction, kind of any other industry that's going to rely on waterborne transit of exceedingly large and heavy components also potentially stand to benefit from the overall industry's improvement to serve offshore wind.
It's
But
great.
that said, the cost of the facilities can make it challenging for some of the other industries to rent the space.
Well, Brent, we really appreciate your time and expertise in discussing this critical asset in moving the offshore wind industry forward here in New York and along the eastern seaboard. I don't know if we've got a next slide, but just want to say thanks to everyone for joining us for this Learning from the Expert webinar series today. A reminder that the webinar recording and presentation slides will be available at nyserda.ny.gov /offshore wind-webinar-series. Our next webinar in the series will be on January 26th. We'll hear from Sean Klein with the Chamber of Shipping of America, and he'll be speaking on harbor safety and navigation. You can register for future webinars through our events page at wind.ny.gov. If you have questions for future topics, if you have requests for future topics you'd like to hear about in this series, please email us at offshorewind@nyserda.ny.gov. Again, thanks for joining us, and we will see you next time.